Okay, so let us do the theorem that we had started yesterday. Let me state it again. So this was a theorem where we characterize it, where we wanted to characterize as when the vertex automorphism group and the induced edge automorphism group are isomorphic. And the theorem states that the vertex automorphism group the vertex automorphism group gamma 0 and the induced edge group and the induced edge automorphism group gamma 1 of a graph G are isomorphic if and only if G has at most one isolated vertex and no component isomorphic to K2. ठीक है तो थोड़ा सा हमने कल भी स्टार्ट किया था but now for this time let's try to do it completely. Now let alpha be any automorphism. Let alpha be any automorphism on the graph G. And let alpha 0 be the action of alpha on vertices of G and let alpha 1 be the action of alpha on edges of G. So then we define a mapping pi from gamma 0 into gamma 1 by divided by pi of alpha 0 is equal to alpha 1. Then we have this, then alpha 1, beta 1. Now this is the image of alpha 0, beta 0. Now this is the, now alpha 0, beta 0 is the action of, is actually the edge action of this alpha of any automorphism on the combination of these two automorphisms, alpha 0 and beta 0. Now by definition, this is actually pi of alpha 0, beta 0. Now because this phi acts on a vertex automorphism in this way. Now, but the left-hand side is, this is pi of alpha 0 and this one is pi of beta 0. So in this way, we can clearly see that this is a homomorphism. So thus, pi is a homomorphism. We need to show that this phi is an isomorphism. Okay, now we will show that this phi is an isomorphism. And for showing that phi is an isomorphism, we will show that this is a 1-1. We will actually show that the kernel of this homomorphism is an identity mapping. And by meaning that the kernel is an identity mapping means that every non-zero, every non-trivial automorphism must be sent into a non-trivial automorphism of gamma 1. So now phi is a group isomorphism. Phi is a group isomorphism because here we are trying to show that two groups are isomorphic. Now phi is a group isomorphism if and only if and only if kernel of phi is the identity of gamma 0. It is the identity of gamma 0. And by meaning that the kernel of phi just contains the identity of gamma 0, so it means that is if and only if this alpha 0 not equal to I0 implies phi of alpha 0, which by definition is equal to alpha 1, and this should not be equal to I1. ठीक है, तो इस तरह से हम दिखाएंगे, और where we define this I0, where I0 and I1 are the identities of these two are the identities of the groups gamma 0 and gamma 1 respectively. ठीक है, तो अब हम दिखाएंगे that whenever we have a non-trivial automorphism in gamma 0, then it is mapped into a non-trivial automorphism. It is mapped into a non-trivial edge automorphism. So now assume that we actually now have to prove two parts in the theorem. We first have to assume that the two automorphisms, that these two groups are isomorphic, and show that the graph can contain at most one isolated vertex and cannot contain a component which is isomorphic K2. And then the other way around, we have to assume these two necessities in the graph and then show that these two groups are isomorphic. So the necessary part is assume that gamma 0 is isomorphic to gamma 1. And once we have the isomorphism, then we can use this definition. So then alpha 0 is not equal to I0 implies alpha 1 is not equal to I1. Now suppose now we have to prove that this the original graph cannot contain more than one isolated vertex. Now to show G has at most one isolated vertex. G has at most one isolated vertex and has no component isomorphic to K2. Assume to the contrary. तो हम दो steps में इसको prove करेंगे. First we will assume that it has at least two isolated vertex and we will get a contradiction, and then we will assume that it has some component isomorphic to K2. Again we will get a contradiction. So assume the contrary, that G has at least two isolated vertices. So let these vertices be, let U and V be the vertices of G, be the vertices of G with degree of U is equal to 0 and degree of V is equal to 0. This is what we mean by saying that the vertices U and V are isolated. We are actually assuming that there are at least two such vertices. हमें दो ही से contradiction आ जाएगा, उसके बाद अगर हमें तीन चार भी होंगे, still we will get a contradiction. Now, how we will arrive at a contradiction? We have shown that alpha 0, we will choose automorphism in gamma 0 and show that it will not be mapped into a non-trivial edge automorphism. So now choose, now define or define alpha 0 of U is equal to V, or alpha 0 of V equal to U, alpha 0 of V is equal to U, and define alpha 0 of W is equal to W for all vertices W belonging to vertex set of G minus UV. तो असल में हम यहाँ पे choose कर रहे हैं, we are actually choosing an automorphism alpha, which is defined in this way that it sends U into V and it sends V into U, and clearly we can see that such a mapping is an automorphism, and this is an automorphism which fixes every other vertex of G. So the only action that it does with the vertices of G is that it swaps these vertices U and V among themselves and then fixes every other vertex of G. Now let's see what is the action of this vertex automorphism on the edges of G. Then, since there is no edge, between U and V, not actually between U and V, since there is no edge incident on U and on V. Since there is no edge incident on U and V. So now try to visualize the graph. If we have a vertex automorphism which fixes all the vertices of graph and swaps these two isolated vertices, then clearly there will be no action, there will be no non-trivial action on the edges of G. Then clearly, your phi of alpha 0 होगा, which is equal to alpha 1 is an identity automorphism in gamma 1. ठीक है? And thus kernel of phi is not equal to identity 1. ठीक है? But we had shown that, and this implies that is gamma 0 is not isomorphic to gamma 1. क्योंकि अगर ये isomorphic होंगे, then we had earlier seen that the necessary and sufficient condition for that is we must have a non-trivial automorphism is mapped into a non-trivial edge automorphism. But now once we have assumed that there are two isolated vertices, once we have assumed there are at least two isolated vertices, then choose any of the two isolated vertices from among all the isolated vertices, whatever the graph contains. Then we choose an automorphism which swaps these two isolated vertices and fixes every other vertex. Then since there are no edges incident on these two isolated vertices, then clearly the edge automorphism induced by this particular vertex automorphism will be an identity automorphism. But since the vertex automorphism was non-trivial because it was moving two vertices among themselves, it was not the identity automorphism, but it is image image under phi, which is the edge automorphism, is an identity automorphism. That means this kernel of phi is not equal to identity 1, and this means that gamma 0 and gamma 1 are not isomorphic.
I not आएगा शायद. Kernel of phi is not equal to I not.
Exactly. So in fact, this should be a set. Okay, so which is a contradiction? which is a contradiction. It's a contradiction. Thus, G cannot have more than one isolated vertex. अब अगर G में एक ही isolated vertex होगा तो obviously उस vertex को हमें हर एक vertex automorphism जो भी हम define करेंगे, we will have to fix that vertex under any vertex automorphism. So that will not make any action on the edges. So therefore, it can contain one isolated vertex, but it cannot contain two, and it cannot contain more. So thus graph has at most one isolated vertex only. Now next thing is, now again assume, again if possible, G has a component isomorphic to A2. Then choose an automorphism, or not choose, we will define an automorphism in our own way. Then we define, let's choose a new automorphism beta 0. We define beta 0. Okay, but before that we need to fix these two vertices. So let again if possible, G has a component isomorphic to K2. Let K2 is equal to UV, or let vertex set of K2 is equal to UV. Okay, then there is an edge between U and V. Then define an automorphism. Define a vertex automorphism beta 0 by beta 0 of U is equal to V, beta 0 of V is equal to U, and beta 0 of W is equal to W for all W belonging to vertex set of G minus UV. ठीक है? Then if UV is the edge E, then beta of E is equal to E. क्योंकि यहाँ पे जो हमने vertex automorphism define किया, U is going into V and V is going into U, and this is the K2. These two are the vertices of K2, which is assumed to be a component of the graph G. तो अगर ये एक अलग component होगा, so that means U पे भी कोई और edge incident नहीं होगा, V पे भी कोई और edge incident नहीं होगा. So this is separately just one K2. तो उस पे हमने vertex automorphism define किया. We swapped those two vertices U and V and then fixed every other vertex. Then the induced edge automorphism जो होगा beta 1, that will fix this V. So UV is an edge E, VU is also the same edge E. So therefore, beta 1 of E will be equal to E, and beta 1 of E dash will be equal to E dash for every other edge. For every other edge, क्योंकि जो बाकी तमाम vertices है उन पे हमने beta 0 define किया है the identity automorphism. सिर्फ ये beta 0 non-trivial automorphism because it swaps these two vertices V and U, but for all the other vertices this beta 0 fixes all of those vertices, so it will fix those edges also, so it will not create any non-trivial actions on those edges. But here we have beta 1 of E is the same edge, beta 1 of E dash for every other edge is the same edge E dash. So this implies beta 1 is the identity automorphism. It is actually equal to I1. Okay. So thus again kernel of phi is equal to I0 and what this जो हमने वहाँ पे automorphism define किया beta 0. तो इस तरह से because this image of beta 0 is beta 1 which is an identity automorphism and kernel we know that it is a set of those elements of gamma 0 which are mapped into the identity automorphism. Now identity automorphism is clearly mapped into identity automorphism. Now this non-trivial beta 0 which was a non-trivial vertex automorphism on G, now it is again mapped into a identity automorphism. So therefore in this case kernel of phi contains these two elements. So which is a contradiction, because we had assumed that gamma 0 is isomorphic to gamma 1. Okay. So thus G cannot contain any component isomorphic to G2. Okay. So therefore we have clearly completely shown that G can contain at most one isolated vertex and cannot contain any component isomorphic to G2. Now conversely, we assume that assume that G has at most one isolated vertex and has no component isomorphic to K2. So we show gamma 0 of G is isomorphic to gamma 1 of G. That means we have to show that the vertex automorphism group and the induced edge automorphism group are isomorphic. Now, if gamma 0 is a trivial automorphism group, क्योंकि कोई ग्राफ ऐसा भी हो सकता है जहां पे सिर्फ ऑटोमॉर्फिज्म जो हम डिफाइन कर सकते हैं दैट्स अ ट्रिवियल ऑटोमॉर्फिज्म. If gamma 0 is a trivial automorphism group, then so is gamma 1, because the trivial automorphisms will always induce the trivial edge automorphisms. So assume gamma 0 has a non-trivial automorphism. Gamma 0 has a non-trivial permutation sending U to V, where U is not equal to V. तो हम एक नॉन ट्रिवियल ऑटोमॉर्फिज्म यहाँ पे ले रहे हैं where this image of permutation, suppose assume gamma 0 is a non-trivial permutation, suppose alpha 0. It's 5 o'clock. And we are defining this alpha 0 by alpha 0 U is equal to V, where V and U are two different vertices. Then since this alpha 0 is a vertex automorphism, then clearly we must have U and V must have the equal degrees. Then clearly degree of U is equal to degree of V and they are not equal to 0. क्योंकि अगर ये 0 होंगे दोनों, then the graph has two isolated vertices, but we are assuming that it has only at most one isolated vertex. So therefore, they have the equal degrees, but both of them are not equal to 0. Now we need to show that gamma 0 of G and gamma 1 of G are isomorphic. Now, depending on these two vertices, U and V, now either these two vertices are adjacent to each other or these two vertices are not adjacent to each other, but they are at least adjacent with some vertex, क्योंकि इन दोनों की डिग्री 0 के बराबर नहीं है, and they are not both isolated vertices, and in fact both of them have degree at least equal to 1 because we have a vertex automorphism which is sending U into V, so therefore U and V must have the same degrees. Now their degrees cannot be equal to 0, so therefore degree of U is greater or equal to 1 and degree of V is greater or equal to 1. That is, degree of U is greater or equal to 1, degree of V is greater or equal to 1. चलो ये हम यहाँ पे लिखेंगे ब्रैकेट में, because we just need that they have the equal degrees and they are both non-zero degrees. Now we will first assume that they are not adjacent and then see what happens, and then the next case we will assume that they are adjacent and see what we arrive at. Now if U is not adjacent to V, U is not adjacent to V, and let E be an edge, let E be an edge incident with U, incident with U. ठीक है, तो हमने किस तरह से ऑटोमॉर्फिज्म डिफाइन किया? वर्टेक्स ऑटोमॉर्फिज्म अल्फा 0 of U is equal to V, and now we are assuming that U and V are not adjacent. तो U यहाँ पे हमारे पास एक वर्टेक्स है और V यहाँ पे हमारे पास एक और वर्टेक्स है. Now there is an edge E which is incident with U. So here is an edge E incident with U. And clearly there will also be some edge E, suppose some E, whatever is an edge, it is incident on V because both have degree at least equal to 1. Now under an automorphism, this alpha 0 of U, this is equal to V. But when these two edges are not incident, that means this alpha 1 of E will not be equal to E, क्योंकि यहाँ पे ये edge E यहाँ पे incident नहीं है, because this edge is not here, because these two vertices are not adjacent. लेकिन अगर इस तरह से होता, अगर यहाँ पे adjacency होती, then we could have mapped this edge E into this edge, but since U and V are not adjacent and we are mapping this vertex U to the vertex V, we are writing U here. Now this edge will not be mapped here because this edge is not incident on V. So then clearly जो alpha 1 of E होगा that will not be equal, क्योंकि ये edge अब यहाँ पे मैप नहीं होगा, क्योंकि ये edge जो है it has its vertex U here, but when we map U into V तो ये edge अपनी ही जगह पे रह जाएगा और यहाँ पे मैप नहीं होगा. So therefore alpha 1 of E will not be equal to E because we have this non-trivial vertex automorphism. Then some edge will be permuted, तो ये edge फिर किसी edge के साथ permute हो जाएगा and that edge will not be this edge E. ठीक है? So this means that alpha 1 is not equal to the identity automorphism. So therefore a non-trivial automorphism, thus if alpha 0 is not equal to I0, then alpha 1 is not equal to I1. Now next, if U and V are adjacent, say E is an edge defined by U into V. So u and v are adjacent and uv is an edge. Now since k2 is not a component of G, thus there is an edge f. There is an edge f with f not equal to E, which is incident with U. So E हमने यहाँ पे assume किया. Now if U and V are adjacent, then there will be some more edge which is either incident on U or incident on V. तो हमने in particular U ही choose किया. हम आराम से V भी choose कर सकते हैं. Then जो यहाँ पे हमने vertex automorphism define किया था, it was sending U into V. Then clearly अगर हमारे पास इस तरह से अब edge होगा, this is U and V. Now here we have some edge F. Now since U is being mapped into, now this is an edge E. Now U is being mapped into V. So now this U is being mapped into V. Then what we see that, तो इसमें क्या हो जाएगा? So if there is this F incident with U, then when we define alpha 1 of F, it will not be equal to F. And so alpha 1 is not equal to the identity automorphism. We had defined this vertex automorphism as it was sending alpha 0 into U into V. And U is not equal to V. So once we have this alpha of U is equal to V, तो ये यहाँ पे अब आ जाएगा, तो यहाँ पे अब V नहीं रहेगा. Now this V will be mapped to some other vertex, क्योंकि एक ही vertex के दो नाम नहीं हो सकते हैं. So therefore जब U यहाँ पे नहीं रहेगा, this vertex U will is now mapped into V, तो ये यहाँ पे आ जाएगा because alpha of U is equal to V. तो यहाँ पे कोई और vertex आ जाएगा, some U dash. So this means that this F is an edge between a vertex U dash and some other vertex. So this means that alpha 1 of F will be mapped, जो ये edge F होगा, it will be mapped to some other edge which is not equal to F under the edge automorphism which is induced by this vertex automorphism. So therefore alpha 1 will not be the identity automorphism. So therefore we had assumed that alpha 0 is a non-trivial vertex automorphism, and now we have seen that it induces a non-trivial edge automorphism. So thus again, if alpha 0 is not equal to I0, then alpha 1 is not equal to I1. So thus gamma 0 should be isomorphic to gamma 1, because we have seen that the mapping is just the identity mapping. That is actually kernel of phi is equal to the identity mapping only. ठीक है, तो इस तरह से gamma 0 and gamma will now again be isomorphic.